All right, so now we're going to continue looking at discrete random variables and probability distributions or frequency distributions of a discrete random variable. We're going to continue with our example of the books and folders in a student's backpack. We're working off of the same frequency distribution and probability distribution here. And what we're going to do in this particular video is we're going to learn how to identify the mean of the frequency distribution, the variance of the frequency distribution, and the probability distribution, and the standard deviation of the probability distribution. Okay. Now the mean is sometimes called the expected value. That's a technical term that we use regularly. In fact, down here you can see E of x, our formula for E of x. That means expected value of the discrete random variable x. Remember, the discrete random variable x can take on 8 values here, and it's the number of books or folders in the student's backpack. So if we select a student at random, they may have 0 books in their backpack. They may have 1 book in their backpack. They may have 2 or 3 or 4 books in their backpack. They might have 5 or 6 or 7 books in their backpack. And what we want to do is we want to know the mean number of books, or the expected number of books that any student will have in their backpack. And we call that the mean, or the expected value. And for each value, like 0 or 1 or 2, there is a probability associated with that. Like the probability of a student having 0 books in their backpack is 0.048. And remember, that can be thought of loosely as like 4.8%. Okay? The probability of a student having 1 book in their backpack is 0.111. The probability of them having 2 books in their backpack is 0.159, and so on. And so let's look at how do we calculate the mean of this probability distribution. Well, here we see the expected value is equal to, and here's the formula. Now this may be hard to read, but I'm going to try to explain it to you. This is capital sigma. It's a Greek letter, and when we see it in math, oftentimes it means add up or sum. Okay, take the sum of. Okay, so what are we going to sum up? Well, what we're going to do is we're going to calculate a bunch of these, and I'll explain what this means in a second. And we're going to calculate one of these for every x. Well, how many x's do we have? We have 8 of them. 1, 2. Now I know this is a 0, but that's our first number. So that's 0 is one number. Number 1 is our second number. Third number, fourth number, fifth number, sixth number, seventh number, eighth number. So we have a total of 8 values that have probabilities associated with them. And so each one of those numbers is going to be calculated, is going to be put into a calculation. And what we're going to do is we're going to take each number and multiply it by its probability. And so here's how it goes. We're going to do 0 times 0.048. And then we're going to add. This means add. This sum symbol means add. So it's going to be 0 times 0.48 plus 1 times 0.11 plus 2 times 0.159. Okay? So let's go ahead and write this all out. So our first one is going to be 0 times 0.48. Now I meant to say 0.048. And then we're going to add plus 1 times 0.111. Then plus 2 times 0.159 plus 3 times 0.143. All right, we're running out of room here, so I'm going to move down to the next line, and I'm going to just put plus 4 times 0.206 plus 5 times 0.127 plus 6 times 0.175 plus 7 times 0.032. And so you can see every single one of these is the x value times its probability. The x value times its probability. The x value times its probability. Okay? So we multiply the x value times the probability, then we add the x value times its next probability, and then add. And we do it for all 7 numbers. We sum them all up. Okay, and so you may want to try this in a calculator, but I'm going to go ahead and do these one at a time. So this equals 0 times 0.048, well that just equals 0, plus 1 times 0.111, well that equals 0.111, plus 2 times 0.159, that's 0.318, plus 3 times 0.143, that's 0.429, plus 4 times 0.206, that's 0.824, plus 5 times 0.127, that's 0.635, plus 6 times 0.175, that's 1.05, plus 7 times 0.032, and that's 0.224. And so now what we have to do is we have to add up all 8 of these numbers, and we get 3.591. And that is our expected value, okay? And so in this case, the expected value, E of x of this, is 3.591. And note, 3.591 is somewhere between 3 and 4 right here. So we expect on average, for a student to have about 3.591 books in their book bag. Now note that they can't actually have 3.591 books because the number of books is a discrete random variable, but the mean does not have to be itself a discrete number, okay? The output values, the observations have to be discrete, but the mean itself does not have to be discrete. That's how we calculate the mean of a discrete random variable. Now we're going to use that number and move on and learn how to calculate the variance. All right, so now we're going to move on and we're going to calculate the variance of a discrete random variable. This one's a little more complicated. Here's our formula, and you'll see that we need the expected value. We need E of x in order to do that. So before anyone could calculate the variance of a discrete random variable, they first have to calculate the expected value of the discrete random variable. And the way that this formula works, the way we identify the variance is, again, we have to sum up a bunch of numbers. How many are we going to sum up? 8 of them, one for each possible outcome. And you can see we have 8 possible outcomes, okay? And here's x. This x is going to once again be the number 0, 1, 2, 3, etc. Okay? And let me show you what we're doing right here. Let me break this out first, and then you can see that we're going to multiply it by the probability, P of x, just like we did when we did the expected value. But let's look closely at this piece right here. This is saying parenthesis x minus the expected value and then squared. So what we're doing is we're going to take each number, like 0, we're going to put a 0 here, then we're going to subtract the expected value, 3.591, then we're going to take that number and square it. So for example, for 0, we're going to do 0 minus 3.591, then we're going to square that number. And if we did that, this would wind up being negative 3.591 squared. And now if we put that in a calculator, we wind up with 12.895281. Now notice I did not round this number. It's important that we not round because we're ultimately going to add up. Well, first we're going to take this number and we're going to multiply it by P of x, okay? And what I'm going to do right now is I'm going to show you probably the best way that you can do this. And in doing this, you're probably going to need a scientific calculator. All right, so here's what we're going to do. We're going to open a parenthesis. We're going to take our first x, which is 0, and we're going to do 0 minus 3.591. We're going to close it. Then we're going to put a square on that. Then we're going to multiply it by the probability of 0, which is 0.048. So times 0.048. Okay, now we don't technically need this little multiplication here if we're using parentheses, so we can actually take that out if we want to. Okay, in fact, I'll rewrite this. All right, 0.048. Now we're going to say plus, because look, we're doing a sum. We're adding up a bunch of things. Then we're going to do this exact same thing with 1 and 0.111. We're going to put a 1 here instead of a 0. We're still going to have a minus. We're still going to have 3.591. We're still going to have squared. But in here, instead of having 0.048, we're going to have 0.111. Okay? So we're going to go parenthesis 1 minus 3.591 close squared times 0.111. Then plus, now we're going to use 2 and 0.159. 2 minus 3.591 close squared times 0.159 close plus. Now we're going to do it with 3. 3 minus 3.591 close squared open parenthesis times 0.143. 0.143 close plus. Now we're going to do it with 4. 4 minus 3.591 squared times the probability 0.206 times 0.206 close plus. Now we're going to do it with 5. 5 minus 3.591 close squared times the probability 0.127. 0.127 plus. Now we're going to do it with 6. 6 minus 3.591 squared times the probability 0.175. 0.175 plus. Now we're going to do it with 7, the last one. 7 minus 3.591 squared times 0.032. And now, when we calculate all of this, and there are several ways we can do this, when we calculate it, we will get one number, and that one number will be the variance, or sigma squared. And I'm going to show you how we can do this in a scientific calculator. So what I'm going to do is I'm going to actually use a graphing calculator. I'm going to pull up the NumWorks calculator. All right, so what I'm going to do is I'm actually going to type it in exactly how we see it here, okay? I'm going to type, we have parentheses, so look, we have on the calculator, we have a parenthesis button, and then I can just key in 0 minus 3.591. 0 minus 3.591. Close the parenthesis, okay? Then I can square, here's the square button, right here, and then I can go parenthesis 0.048, 0.048, and then close the parenthesis. So this is our first one. And then if I just press plus, I can continue. Parenthesis 1 minus 3.591, close parenthesis, squared, times 0.111, close parenthesis, then plus. And it's just going to keep going. Now we're eventually not going to be able to see everything at once, but we can keep keying in. I'm going to go ahead and fast forward here. All right, so I just finished entering it, and you can see here's the 7 minus 3.591 squared times 0.032, and you can see that I did it for every number. This one's the 7, here's the 6, there's the 6 minus, okay, then we did it for the 5, and here's the 5, and we did it for the 4. So we did it for every single number, and now all we have to do is hit execute, and our answer is 3.490614. We're going to go out to 6 decimal places here. There's a good reason for that, and I'll tell you in a couple minutes. So 3.490614. So 3.490614. Okay? And so this is our variance. Now, I understand. Don't say to me, wow, that's a lot, Mr. Ryan. I know it's a lot. I just did it. I know it's a lot, but that's how we calculate the variance. Now, on a test or something like that, I'm probably not going to give you 8 numbers. I'll probably limit it to maybe 4 or 5, okay? But you've got to practice this, and you've got to know this formula right here for calculating the variance. Now, the last thing we're going to learn how to do is the standard deviation. All right, so the standard deviation is basically, we've learned this before, it's just the square root of the variance. And so if we want the standard deviation of this particular discrete random variable, basically we just have to do the square root of 3.490614, which we can do in the calculator. So square root of 3.490614. This one we can round because we're at the final answer. 1.868. So the standard deviation is 1.868. Okay? And that is how we calculate the mean and the variance and the standard deviation.